Okay, so I'll give you a list of intervals, pairs of numbers like 1 comma 3, 2 comma 6, 8 comma 10, blah blah. And your job sounds easy. You have to just join ones that touch each other. But there's a small trap. When you join two intervals, the new one can suddenly touch a third one you already passed. Right? Missed that? And your answer is wrong. Today we will solve LeetCode 56. Merge intervals. We will start with a slow way, see why it's slow, and then build the fast way step by step. By the end you will just know the answer and you will understand why it works. So okay, let's start with understanding the problem. Okay, as we do. So, okay, each item has a start and end. 1 comma 3, 2 comma 6, a start and an end. Okay, so each item has it, and two intervals overlap if they share any point. When they overlap, we join them into one bigger interval. Okay, so look at 1 comma 3 and 2 comma 6. Look at these. Okay, the first ends at 3 and second starts at 2, so they share the space from 2 to 3, right? Because if it ends on 3 and it starts with 2, so yes, it starts somewhere between 1 comma 3, right? So they overlap. This means overlapping. Okay, so what we have to do is, like, so why when do two intervals and overlap exactly? So do not touch only when one is fully to the left of the other, but so one ends before the other even begins, right? So yes, what we can see is that this first should be always less than this last, then only it will overlap. No, right? Because two would be like somewhere in between. Okay, so yep, so keep this in your head, and every bug in this problem comes from getting this wrong. Now let's try the beginner way first, so you will feel why we need something better. Okay, so okay, what we can think of the brute force approach, or we can say the slow approach. So let's move to the whiteboard first. We'll move to the whiteboard and then we will find out what it is exactly. So let's take this example, right? We will work on this example basically. So now what we have to do is, the simplest idea is to check every pair of interval. If any two touch, join them. Brute force is like this only. Now we work on loops, nested loops, loops, right? So then start over from the beginning and check again. Keep doing this until one full check finds nothing to join. Why start over every time? Because joining two can create a new overlap. See, see, like if we run the first loop and we find these two are overlapping, right? So we join it. Okay, and by joining we get 1 comma 6, right? After we get 1 comma 6, then if we continue doing the we continue running the loop. Okay, so now 1 comma 6 might touch 5 comma 8. Let's say there is a 5 comma 8, so it can like touch 5 comma 8, right? And it's not a real interval because it is not real overlapping. So like there's a trap, so one pass is not safe. We repeat until nothing changes, right? So what we do exactly is, let's say, okay, let's do it step by step. We'll understand it better. We are doing step by step the brute force approach, right? So I picked this one on purpose. Watch a hidden overlap appear. Okay, so what we will do is we will replace this 15 comma 18. My bad, we will write this. Okay, so instead of this we will take a bit hard example so that we understand. So we'll delete the output first. So this is the example, let's say. Okay, so now what we'll do, we will first compare. We're running our first loop, so we'll first compare these two, because let's say a loop is here, so these will convert into 1 comma 6, right? And after it converts to 1 comma 6, so yep, we will remove 2 comma 6 and we will have like these two we will remove, and we will have 1 comma 6, then 8 comma 10. Well, like in place of these we get 1 comma 6 if we write here. Okay, so now we join the first two. Now we start over. So now list is 1 comma 6, 8 comma 10 and 5 comma 8, right? So now compare 1 comma 6 and 8 comma 10. They do not overlap because 8 is not less than 6. Of course it is not lying in between here. Okay, so we do nothing. Then we will compare 1 comma 6 and 5 comma 8. Yes, they overlap because 5 is less than 6, right? So what it becomes, it becomes now 1 comma 8 because we merged 5 comma 8 and 1 comma 6, and 8 comma 10 is here, right? So it is our current scenario. Okay, so now there's the hidden overlap. 1 comma 6 could only reach 5 comma 8 because it already ate 2 comma 6. So start over again. So now list is 1 comma 8 and 8 comma 10. So now we'll compare 1 comma 8 and 8 comma 10. So now we'll join in, and yes, 8 is lying between, yes, because 8 is 8 like equal to 8. So yep, now the list becomes only 1 comma 10, right? I'm doing nothing wrong here. And after that, the list is 1 comma 10 only, and now only one interval is there, nothing to compare, so nothing changed, so we stop. Answer is 1 comma 10, correct. But look how many times we started over. 4 passes for 4 intervals. That's why it's slow. Let's fix it. Okay, this was the brute force approach. We did nothing, we just ran and ran different times. For each interval we ran one loop, and then we came to the answer, which is 1 comma 10. Like if we say here also, they compile into 1 comma 6, then these two compile into 1 comma 10, and these compile into 1 comma 10. Okay, so yeah, this was the brute approach. Now we will move to the big idea. The intuition is, okay, so why did this slow way need so many passes? Because the intervals were in random order, right? Like these are in random order, 1 comma 3, 2 comma 6, 8 comma 10. They are not like they are in random, right? They are scattered. So here's the key idea: if we sort the intervals by their start, then everything can join a group, sits right next to it, no more jumping around, and just one clean pass left to right. See what I mean is, let me just copy this so that, okay, just a sec, my bad. So we will just copy these, and what we can do is we can copy this, and what we can do, we can just sort it, right? So 1 comma 3, 2 comma 6, and then 8 comma 10 would just shift, and here it would come 5 comma 8, and 8 comma 10 would be here. Okay, so now we sorted this. Okay, let me erase this. That is okay, my bad. We are not erasing this, bro. What are you doing? Yup. So okay, now we have sorted the array, the 2D vector. Okay, so this is the sorted part. So now see it. After sorting, the three that form one group line up as neighbors. See, 1 comma 3 and 2 comma 6 merged, and then it merged with 5 comma 8. So yes, they are in the sequence now. So you got the idea. Then only 8 comma 10 goes to the end. Yup. So now one sweep can build every group. So why sorting works? Yup. Let's prove sorting makes one pass enough. Say we are building a group, and the farthest right it reaches is E. Now we'll look at the next interval, S comma E. Because the list is sorted, S is bigger than or equal to every start before it. Okay, so yeah, this is the main problem, like main problem solver. Okay, so yeah, the fast way would be the greedy approach. So what we'll do is, this is called a greedy because at each step we make one simple choice. So we will understand it in detail, we will do a detailed dry run. So yup, and we never go back, we just keep selecting and merging. Okay, we will sort by start first, then put the first interval in our answer as the current group. For each next interval, if it touches the last group, grow that group's end. If not, add it as a new group. So yep, let's dry run it first. We will understand what we are exactly doing. So we will make a new data structure. We can say we can make a result 2D array. Okay, we will name it result. So what we will do, we will start traversing it, of course. So first of all, this first element we will push it in here. Okay, first would be push it in here without any disturbance. It will be pushed here, it is necessary. Okay, so now what we will do, we will now move to the next element. Okay, so last group was 1 comma 3 and current is 2 comma 6. So 2 is less than equal to 3, that means they overlap. Okay, so now we will grow to max of 3 comma 6, like the ends, right? The ends. So max would be of course 6. Okay, not of course, because this can also be greater. Yep, anything would be the case. So yep, we will merge them. How will merge them? We will grow the end to the max of this element end and this element end. So it would be, in a case, what it would be, 1 comma 6, right? So yup, we now the result is basically we are removing this, and now the result would be Now the result would be 1 comma 6, right? Because we got a new, okay, we got a new group in the array. Okay, so now what we will do, now our current element is 5 comma 8 and our last is 1 comma 6. So 5 is the less than 6, yup, is it less than 6, so they overlap. Now we will take max of 8 and 6, so max is 8, so we will grow the n to 1 comma 8. So now result will store 1 comma 8, right? No problem. Okay, now we'll have the current element on 8 comma 10 and last element would be 1 comma 8, right? So max of 8 comma 10 is 10, so it will be 1 comma 10 in the last. So result will be storing 1 comma 10 at last, so the answer would be 1 comma 10. So same input as before, but now one clean pass. Every step just checks the last group and grows it. That messy join that goes the slow way, a whole extra pass. Here it's just the next line. So answer 1 comma 10, same result, 1 pass instead of 4, just change. Okay, so this was basically the optimal approach. We just need an extra data structure and nothing beyond that. And we will need basically in the code, what we will need just to like first sort, we will need an vector which is the result vector that we are using to store it, and we will just have to run one for loop to just traverse the array one time and we will be done. Okay, so the time complexity would be sorting. For sorting we will use n log n because we will sort using the stl function, so its complexity is o n log n, and for traversing ones we will use o of n, so the overall complexity would be o n log n. And space complexity would be, because we are using an extra data structure vector, it would be of n. And if we talk about the brute force approach, like the brute force approach that we discussed, brute force approach complexity would be like basically we used a loop to first traverse it, and then outer loop runs n times. N is the like basically the size of the like intervals, right? This size total, this is 4, right? So outer loop runs n times and inner loop also runs n times, so each overlap takes of 1, so total is of n square because it's nested loop. And space complexity is basically of 1 because we are not using any data structure extra, but in this we are using, but the complexity is much low. So now we can move to the code part. So yep, now we will move to the code part. Let's go. Okay, so let's start the coding part. It's much easy now because we know the approach in detail. It's not that much hard, it's not that much easy. It's a good approach to solve these kind of questions, and it is a frequently asked question in the interview. So you can first start with the brute approach that I told, and now then after that you can easily tell this optimal approach, which is much better. So what we will need basically, first of all we will need an 2D array to store the answer, right? Yes, right. So first of all we will need a 2D array, we can say it answer. Okay, now what first step was to sort the array. So which array we are sorting? Intervals dot begin. I'm assuming that you know basic STL, the basic STL functions, so I'm not going to explain these, of course. So we first but just sorted the array, and we will start, we'll always push this first element in the array first, right, as we talked about, because we are using this to compare with the next elements, right? So yep, this would be pushed right away in the starting only. So push back, what will push back? Intervals 0, the first element, right? Okay, so this was the first step. Now we'll start running the loop. So we have already pushed the first element, so we'll not start by 0, we'll start by 1th index. And how much will run? It will run till the size of intervals array basically. So the size till the size, and I plus plus would iterate. Then what we have to do, we have to check the condition that we talked about, that if the intervals I of 0. Okay, what does that mean? Okay, what does this mean? Just a sec. Yep, intervals, oh my bad, intervals. Okay, so I comma 0, if it is less than equal to, what is it less than equal to? It should be less than equal to answer dot back 1. Okay, so what it means, right? Exactly what it means. So in the array currently we have 1 comma 3, right? So what was the condition? That this 2, the ith, this is the ith, because it is already stored. I is here currently, I is here at 2 comma 6. So of I, like we need to compare 2 should be 2, this represents 2, so 2 should be less than equal to answer dot back, like it is used to just fetch the last pushed back element. So it was 1 comma 3 in our case, so it's 1th, like it's 1th, so it is 3 of course, so it should be less than equal to 3. This was the condition we talked about, right? So if this condition satisfies, okay, if this condition satisfies, so what we will do is we will just change the answer dot back 1, the end, to the max of, as we talked about, the max of answer dot back 1, of course, answer dot back 1, and max of 6 and 3. So 3 is intervals I1, right? So max of intervals I1 and answer back 1, both the ends we need max of these two numbers, 3 and 6, right? So yep, we'll store it here. And else if this does not satisfies, then what we will have to do, then we have to just push back the latest element to the results, right? Latest element, which is intervals of I. Okay, so then we will compare, like if it does not satisfy the condition, so it will also be pushed back, because now we will compare the next element through this, okay, because it is sorted manner. So yep, like this it works. And then at last we can, after the for loop is fully run, so then we can return the answer, and this should get us what we want. It should get us what we want. Yep, it does. So we talked about the time complexity already. It is for sorting we need O n log n, and for the one for loop we need O of n, so total is O n log n. And this is an extra data structure here, so O of n is space complexity. So that was all for this merge interval problem. It is kind of a medium level problem, we can say. It is not that much hard, but yes, it is an important problem. So that is all for today. Thank you so much for watching. Bye bye.